Hello everybody, Robin here. We're going to look at object-oriented programming and this is suitable for OCR and for AQA and any other exam board. So I'm particularly looking at it from an A-Level perspective though. So with object-oriented programming, what we're actually talking about is the structure of data, not a data structure. There's a distinction between those two things. A data structure is where you store data and how you go about storing that data, whereas the structure of data is how you organise those different types of storage methods, if you like. So how are we going to group and organise the range of variables that we've chosen in a particular situation, and just kind of having that sort of awareness of the management of that. When we manage our data, the structure that we use, we call this a class. And in other words, we're thinking of what are the qualities of the generic thing. What we then would want to do is be much more specific, and therefore would be the object. And then when we're talking about our specific thing, we call that, like I said, an object, and then we call that an instance of a class, just as a term that you want to start getting used to. So when we're talking about a class, like I said, we're talking about generic things. So we can talk about a car, for example. All cars have roughly these qualities. They all have wheels, they all have a type of roof, they all have windows, they all have a sort of a car registration number, they all have an engine, they all have fuel. There's all sorts of things we can say are true of every single car. What we can also say about cars is that they accelerate and they brake and they turn left and they turn right. So in other words, they perform actions. So when we're talking about the qualities, such as the wheels, etc., we call that an attribute. And when we're talking about the actions, we call that a method. Once we want to be more specific, so in other words, I want to talk about this sports car that's a Renault that has a car registration of 001 P23, for example, we therefore are now talking about an object. We're much more specific about that type of vehicle and what it is, and therefore we can distinguish one vehicle from another. So in other words, our objects. If we look at this is called a class diagram. And you can see that there's a particular layout to this. Notice it's got the curved square around it. First of all, we have the name of the class. So in this case, it's called car. Then we have the attributes associated with that. So I've just included reg number, brand and engine just for simplicity. And you can see that the data type has been set for all of those as a string. We also then have the methods, and they're the actions that are performed by the car. So like I said before, accelerate, brake, turn left and right. What we need to be able to do, and one of the sort of important things you need to be able to do, is to create a constructor. And what I mean by a constructor is the code on the right hand side where you can see there, Renault equals new car, Renault reg number, our reg number from before, Renault brand, Renault, and then Renault engine, petrol. You need to be able to write that if you are asked to create an object as an instance of a class. That terminology again coming in. So this is a kind of a typical sort of thing you'd put as an answer. Generally speaking, in an exam question, you'd be actually given that data and you'd be therefore asked to sort of appropriately create it. What we are often asked is either to not include getters or setters, but to include them, and therefore we would need the code to do so. A getter displays the current value of an attribute. The setter sets and updates that value. So it gives us a control over what we're using and how it's used. And that is part of what we call encapsulation. I will come back to encapsulation in a moment or two. So as you can see here, I've got the same class. You can see that I've got the attributes of the reg number, brand and engine, but now with the methods have changed. So rather than being actions, actual physical actions like we had before, accelerate and brake, instead these are now data actions. And obviously this is the way you're much more likely to deal with it. So in other words, what we want to be able to do is get what the current registration number is stored as, or we want to update it and set it as something. You can see that for all three of those methods, the ability has been given to get and set. When I talk about encapsulation later, I just want you to sort of preempt this. If some of those didn't allow me to say set, what that would mean is I would only be able to view the data that was already there. I wouldn't be able to update it. And that gives us a control, a mechanism over the way that data has been used. And obviously that's been pre-thought and pre-decided as well. You can see on the right hand side is typical code. So this is Python code for doing so. So you can see that we've got a function, we've got the get, it's coming from the self being the class, and therefore it's then returned and gives that value. And again, we can set that value, and it takes whatever variable has been given to register, so whatever data has been added to that variable, and then puts it into the class where it's stored. Okay, so one of the key benefits of doing class structures is we get the usage of inheritance. Inheritance, in the same way that inheritance in real life, you borrow the qualities from your parents, so they can be the good and the bad qualities, but the way you look, your personality, how you sort of react in different situations, your intelligence level, all sorts of things like that. In the same way, we can inherit from a class into another. And the big benefit of this is you don't therefore have to have duplicate classes that have the same data inside. In other words, you create one class and you borrow the elements that you want to use. In other words, we therefore have what's called a superclass, or the base class, that's the main one. In our instance, we had a car. And then you can have a derived class. In other words, qualities that are more specific, more unique. So they could be, for example, qualities of an electric vehicle as opposed to a petrol-driven vehicle. You can see here, I've got 3 different vehicles. You can see that they've got a car, van and motorbike. And notice with these, they all have exactly the same attributes and the same methods. In other words, that's just repetition, isn't it? We don't want that. That's inefficient. So in other words, what we can do is bring that into a superclass. You can see the qualities have now been put into a class called vehicle. And now, if we're talking about a car, we can inherit the qualities from the vehicle class and then be more specific about any ones that are directly to do with a car versus a van versus a motorbike. And obviously a motorbike has different elements, doesn't it? It doesn't have doors, for example, or it doesn't have windows, or apart from the windscreen, obviously. But it just gives you that control, so you can borrow the things you want to borrow and ignore the elements that you don't want to use as well. So really quite a powerful control then we have over the structure of our data. Again, you can see here a little bit more detail. So again, we can have different types of van if necessary. And again, they would then be a further subclass, but it's still inheriting the original structure of the vehicle above it. Again, as we're getting more and more subclasses, our elements are becoming more and more unique. So we actually end up with unique methods just for a van type 1 versus the van type 2. Okay, so one thing I'm quite keen to show you is a few Python examples of this, just so that you can take this away. You can obviously try this out and code it yourself, and you can kind of get a better understanding of what's going on. But also, you're expected in an exam to be able to write the pseudocode for this. So I kind of feel like if you're already comfortable with doing the Python of it, you'll be much more comfortable, therefore, doing the pseudocode in turn. So you can see I've got a class diagram here. Notice in the class diagram, the arrow always goes up. You may not have noticed, I didn't mention it, but that's true in these as well. The arrow is always going up. That just represents that it's inheriting from that class above. What we've got then is our attributes and our methods. And you can see that I've also then got a player. What this means, therefore, is that the player class is a subclass of the superclass of team and will derive the different methods and attributes from that class. What we've also got an ability here is to override a method in team details. I'll come back to that in a moment or two and kind of explain that in more, but just want to point it out while we can see it. Okay, so in our code, if we were going to create this class, we would write something along the lines of this. So we have a function where we're setting up self being the team name, stadium and competition, so that particular class, and then we can have a second class, our subclass in this case, of a player. And again, this player is inheriting from above. And you can see that team name, stadium and competition have been passed as parameters down into this class from the superclass. You can sort of see that sort of 1, 2, 3, 4, the fifth line down in that second subclass. Okay, so I mentioned encapsulation before. Encapsulation is the ability to hide data and to protect data. You do this in databases as well, where you don't allow certain users to access certain tables. Well, we get the benefit here. In other words, we're controlling the way that the data is used, how the data is managed, who can see what and how. And it gives us loads of benefits. Obviously, prevents tampering and things like that, but also means that you can protect users from changing data if you don't want them to. All sorts of big benefits from it. So some of the things we can do with encapsulation now, we can set attributes as private. This works in a similar way to the way variables can be local or global. In other words, if you remember with a local variable, that will only work within the function that it's in, whereas a global can be used across the entire program that you're using. Whereas with our private attributes, it's the same kind of idea in as much as that it becomes a local to the class. It just has a different terminology, so we've got to be careful with our terminology that we're using the right phrase. So it's private if we want it to be local within that class. Public would therefore be more accessible across other classes if we wanted it to be. Okay, we can also protect data, so we can set up things like validation. So you can see here that the length of a T name has to be greater than 3 characters long, otherwise it's going to reject it, and therefore that can be built into our set methods, and therefore we're ensuring that the data within our sort of system is being consistent and accurate as it's used. Again, here you can see an example of some getter methods. You can see they're quite straightforward. So we just get from a function and then we return a particular attribute we're looking for. Again, it works in the same way for both the classes. You can see there's very little difference and they're quite repetitive in many ways. So it should be something that you can get used to quite quickly, I would hope. Again, you can see them for setters. So we can sort of set the team name, we can set the stadium, competition, etc. And remember, like I said before, if we didn't create one of these, say for example the competition, we didn't allow it to be set, we therefore would be meaning that we can't update that data value. In other words, it's protected as a result of that. So really quite useful. Okay, I just want to talk about polymorphism next. Polymorphism is an interesting concept in as much as it has similarities to inheritance, in as much as that you can borrow from a superclass. But what makes it different is that you can override from that superclass as well. What I mean by overriding is changing and manipulating the data that's in the superclass in the situation that you're in. So rather than having to write the class out again, we can use it, but we can override the data that's in there. So if we look at an example of this, what I mean is that we can have, here you've got some Python code. So again, I would encourage you to try this out, but that you can see that we've got a function where it's going to print out the team, the stadium, and the competition. We can then also have a second subclass, which has got for the player, where it's going to give their position and the fitness of that particular player, whether they're fit to play or not. What will happen now is if we're just talking about the team and we want to just output the team, we'll get an output of, say, the team name, the stadium they played in the competition. But with the player, it will take that information as well and then add to it. So as well, like alongside it. So our position and our fitness. So we'll just show you an actual example. You can see that with the team output, we'd have Barcelona, Camp Nou, and La Liga. And then if we output the player, we would then get Barcelona again, Camp Nou, and La Liga, as well as striker, and also that they're fit to play. What's special about polymorphism, though, is we can also override. So if this player actually plays for, say, Manchester United instead, we could have Manchester United, Stadium, Old Trafford, competition, Premier League, but we can then use that the position is still a striker and the fitness is still that they're fit to play. So you can see that we've not had to write the structure out again. We've just used the structure that was there already and then manipulated it for the situation that we're in. So really quite a useful and powerful tool. Like I said, I encourage you with all of this to go back through, pause on each of bits of the code, sort of have a go at creating it, and then creating your own instances as well, and just getting used to the way that it works and manipulates. And all the best with it. Thank you for watching. I really appreciate it. Really hope you found this useful. If you've got any questions, please do let me know. I really want to help you understand this as best as I possibly can. So, like I say, thank you for watching. Please do give us a like and a subscribe. Otherwise, I'll hopefully see you again. Thanks a lot. Bye.